Hi, everyone. This is the last talk for the day. And today I'm going to talk about how to build machine learning using medical record for healthcare industry. My name is Adrish Sannyasi. I'm a solution manager in Google Cloud Healthcare Life Sciences. So the talk has several components. First, I'm going to go to the background of healthcare and why AI in healthcare and healthcare data, why or some of the challenges you might see with the healthcare data. And then I'm going to go and demonstrate one GCP pipeline that we built using healthcare data and all the GCP tools like BigQuery, Dataflow, and the AI platform. So before we dive into the detail, let's talk about why machine learning in healthcare. What are the high impact things you could do with machine learning? Today we see AI solutions are used across the healthcare spectrum. To get us started, I'd like to highlight a few reasons why you need machine learning in healthcare. A sheer volume of clinical data is overwhelming us. It could be electronic medical record data, medical image, or genomics. No one can keep up with those medical evidence that is accumulating every day. AI can make sense of this large amount of data associated with the diseases or a single patient to highlight the relevant information needed to best guide the treatment and care for each individual patient. AI can also improve clinical reliability and be used to help identify relevant information pertinent to the correct diagnosis or the treatment of a patient by mining historical patient records. It can learn from patients like me. For example, AI solutions are now used to predict visits to emergency department or to predict which hospitalized patients are at high risk of deterioration. Finally, AI solution will be useful for solving healthcare data-related issues as well, such as data normalization, data quality, and data annotations. Healthcare administrators can use AI to better run their business, improve operational efficiency, and the patient outcome. AI tools can tackle tedious and mundane tasks because they don't suffer from fatigue, distraction, and the moods like human does. Now, AI solutions are emerging in which the data entry and administrative tasks will be automated. Recent research demonstrated that deep learning sequence models are more accurate than traditional machine learning models on electronic medical record data. It can use thousands of variables. One of the Google studies shows it used 150,000 variables compared to average 27 variables in traditional models. In addition, it achieved this result without doing much feature engineering work. So now it is much easier to create models in a highly scalable fashion. Now let's look at some of the forces that is shaping the healthcare industry today. You see in the post-COVID world, there is a significant pressure on cost containment, that the reimbursements are getting tight, and also at the same time, revenue are plummeting. So healthcare organizations are looking for efficiency, looking for business transformation. At the same time, they want to create lifetime patients so that they can do variety of services for them. At the same time, patients are becoming much more like a consumer. They want to use telehealth, they want to use mobile devices, and a lot of them has wearables like Fitbit and Apple Watch. And those creates opportunity for more and more data. And then at the same time, we want to actually improve the workflow so that we can take advantage of a lot of this data without overwhelming our physicians. At the same time, security, privacy of the data, and interoperability of the data is very important in this space in order for us to take advantage of all the data that you have in this industry. In general, I talk about how AI could be utilized in healthcare. There are three ways you can generalize those ideas that I talked about. One is like where expertise is limited, for example, in radiology and others, where algorithm can scale and enhance certain expertise. Lots of data, if you have to look through, it is very hard for human to do those things. So that's why the AI could be used to take advantage of this data that is created out of routine care. And most importantly, it has to be actionable. Whatever AI insights generated, it has to help clinicians or administrator in making some decisions. There are some examples here that the people are already doing out of electronic medical record. For example, predicting length of stay so that administrator can better manage their hospital system, or clinician can better care for their patients. And there are a variety of other things like who is likely to visit ED next month, and what can I do now to prevent that? So in summary, in terms of scalable deep learning, it enables high accurate model without explicit feature engineering, and Google researcher has proven that now. At the same time, current healthcare system is really inefficient and generates lots of data. So at the same time, there are significant opportunities for data-driven transformation. Now let's look at in detail what effective AI solutions or ML solutions really means in healthcare settings. The first thing is utility. It has to have some purpose of solving a problem that currently faced by industry. The second thing is feasibility. The feasibility is mainly two-front. One is the workflow integration with your business workflow or clinical workflow. And the next thing is integration with the current IT systems. Sometimes those are legacy systems, not easy to integrate. Lastly, impact. We have to think about impact either as on clinical care or the patient outcome and operational efficiency. Without these three, combination of these three can decide whether a ML solution would be effective in a healthcare setting. So now let's give a concrete example of how to know if a model will be effective in helping the clinicians or administrator. In order to do that, one way of addressing this challenge is to look at the patient timeline. For example, if patient gets admitted to a hospital today, there are two things generally available to a model. One is what happened to this patient in the past. The past medical data may be available, and sometimes it may not be available. But also you have data that is getting collected as a part of your current admission. For example, lab test, vitals, and your current medical history, things like that. So those data will be utilized as an observation. And then the model has to predict. So for example, here, whether somebody will get readmitted after 30 days, 90 days. And if you can predict it earlier in the admission, it's much more easier for administrator or the clinician to take some actions on the data. So timing of the model, when the model is actually predicting, is really important. Another thing here you can do is you can predict something years in advance, months in advance. It is possible maybe to do, the prediction may not be right, but that may help having a better treatment plan for the patient, so that, let's say here, I'm showing you renal failure, how to prevent renal failure from happening if a clinician can take actions right now. So in summary, we have to think beyond accuracy and precision as a measure of the model. You think in terms of utility and impact. Accuracy does not guarantee impact in healthcare settings. When done well, healthcare analytics or AI could open up a lot of opportunities for improvement. Now let's look at healthcare data. In order to do model, first you understand what are the data types, how to normalize your data, how to take advantage of some of the unstructured information, and also discuss some of the issues that you might face, like data quality issues or the bias issues in the data. In terms of the data sources, there are mainly three types. One is the structured data sources, for example, database tables. It could be a message structure like HL7v2, which is a standard used in healthcare settings. It could be some of the public health open data sources available from CDC, like social determinants of health data or the FDA adverse event reporting data. Those could be used as a feature in your model. And there is a lot of other opportunities to gather feature. For example, this unstructured healthcare data sources. Sometimes lab results, although it looks structured, come to healthcare system as in a PDF. Especially if the lab is outside the healthcare system, they're probably coming from some specialized microbiology lab. For example, COVID testing is probably coming from other places, not exactly from the hospital. Then we have clinical notes. Clinical notes is what doctors write about you when you visit them. It could be a progress note, could be a discharge summary, and things like that. And they are not like ordinary English. There's a lot of jargon, a lot of medical language that is used so that it looks very different than ordinary English. And then you have medical images like chest x-ray, NS, etc. And also you have medical signal, which is coming from ECG and electrocardiogram and other places, but that also looks like unstructured data. But these data sources are rich with a lot of features that you could use in your model. So now let's discuss about some of the normalization techniques that you might need to employ. And some of these cases, the normalization might be done as a part of data warehouse. But if it is not done, then you have to do that as a part of your machine learning data processing work. So for example, here I'm showing you a data model that is standardized by HL7. It's called FHIR, Fast Healthcare Interoperability Resources. And it has two advantages. One is it is getting widely adopted. Now it is all in a rule published by CMS that all provider and payer must support this kind of format. And second important observation here is it supports two types of modalities. One is it is a data model so that it has standard table structure, all the columns and things like that. But also it supports a REST API endpoints. So it has, you can access the data through API or you can access the data through SQL. And in Google Cloud, we implemented both of this kind of way of access. Some of the example of the healthcare data tables are like patient, encounter. Encounter means when you go to hospital, there is something written to your record that's called encounter, and they also have procedure, condition, observation, and things like that. Now, all of these things are implemented in Cloud Healthcare API, and we support the latest FHIR format data, but also we support storing of data in a legacy format like HL7v2 and others. On top of it, it provides a couple of other additional capabilities like data de-identification, which is very important in healthcare because you want to de-identify data in many cases before you give access to your machine learning engineer. And then it provides capabilities like consent management and also help you annotate data that you might need. And this is kind of an overview of the functionalities of Healthcare API. It provides import functionality as a streaming and a bulk import, but also it provides export. You can export data streaming or bulk to BigQuery from the API. And you can interact with the API using standard REST interfaces like create, get, list, delete, and things like that. And you can notify the presence or change of your any resources through PubSub. So the other program can listen to PubSub messages and can do the subsequent operations. On top of the healthcare API, we're also invested in creating this data harmonization suite, which is basically normalizing the data across variety of source systems. It does a bunch of things. It does field mapping, which is very obvious. But more importantly, it will help you manage the semantic terminology of data. For example, healthcare uses a lot of codes like medications code, disease code, procedures codes, 100,000, close to 100,000 codes. And these codes are not standardized in the legacy systems. Sometimes you have to then map those codes and standardize those code system as well while you are mapping the data. And we also provide various types of open source tooling for the community and some example of HL7v2 to FHIR mappings and so forth. Next comes healthcare knowledge graph. We talk about this terminology and how healthcare code are important. So actually, a lot of the researcher has done the work for us. They created a knowledge graph, healthcare ontologies, which is a linkage between variety of terms and concepts. For example, if you say heart attack, and someone might say the same thing as myocardial infarction. So how do you know heart attack and myocardial infarction is the same concept? This is encoded in a knowledge graph. Lastly, another important thing is this knowledge graph can be used to derive clinical knowledge. Like what is the symptom for a heart attack or symptom for certain medical condition? What is some of the disease condition? What is the medication that is used for certain diseases? So all of these things are codified so that you don't need access to expert in order to derive this. And this is available open, UMLS and the other website that I mentioned here. You can go to that and then download the information. And this is a concrete example of that. One is called SNOMED CT, which is for the disease and symptoms and things like that. And there's another example is RX norm, which is information hierarchy for medications. Next concept that you want to take care of is the Codeable concept. So Codeable concept is where we are using this terminology and to map the legacy code to standard code. And there is a certain syntax you use in order to do that. And FHIR has a standard way of doing these things, how you want to name a legacy code versus a standard code. And using all of this concept, now let's look at one harmonization example. So here I have the source system data on the left-hand side. And source system data is mapped to certain FHIR fields, like an observation ID and a subject ID and things like that. And when I'm doing this, I need to do a couple of things, like standardizing the unit or conversion of the unit at the same time. And then harmonization of the code. For example, legacy code is 1655600 or the harmonized code is 17861-6. And while I'm doing all of these things, the final output would look like something like this. We have the FHIR output on the right-hand side, and this is a FHIR model for observation, and you can see how various concepts are utilized in order to create this kind of report, this kind of output. Now let's look at, so far we looked at structured data. Now let's look at how unstructured data could add this to this for list of features. So the integration of unstructured data could be done using OCR technologies, or in many cases, this data might be in a text format, so we can directly apply natural language processing API on top of it to create healthcare specific entities. It could be problem, could be a medications, could be a procedure, etc. And you can then attach it to appropriate resources in order to make sure that this data is actually could be utilized by the downstream application. And this is one example of that, how source data has this kind of bunch of nodes, and in the NLP extraction, we are able to extract certain medical terms and add those terms to appropriate tables in the destination standard format. Now, not the last one, is the next look at this concept of data quality in healthcare. There are two kinds of issues here that we want to deal with. One is conformance. You have seen a lot of the data format like H7V2 and etc. In some cases, their schema changes with respect to time. You can have the schema changes probably every 6 months, or some upgrade happens to the source system. So that's one of the issues to worry about. And the second issue is accuracy. Whether the data you have, is it the data is right? Like discharge time is important if you calculate the length of stay, but do we have the discharge time in the data? And then even if you have the data, is the data is in the right range? Like, is it have duplicate patients, whether temperature values are out of range, because those things might affect the way the machine learning model works. And last important thing I want to bring about is sources of accuracy and bias that you might see in electronic medical record. For example, the patient is, let's say one patient is seeking for care because they have symptoms and some kind of or some kind of acute illness. So that itself could result into selection bias. So let's say people who do not have insurance or may not want to spend their deductible may not be looking for care. So that's one way of introducing selection bias. Now, let's say now you come to some kind of clinic or hospital, and then experts giving you exams, diagnostics, and a prescription. So that's a classification bias, because sometimes you do this test, sometimes you may not do this test. So that may introduce the class bias. And then oftentimes physician will enter information a lot. More often, other times it may not be entering a lot of information, and also some information are in EMR and others are in medical image and scanned image. But if you are not looking at the other data sources, you may be introducing information bias. And then once your billing or the coding happening for your encounter, then you could run into selection and classification bias as well, because your co-billing agent can change some of the data for a variety of reasons. And then when you go to and do adjudication and the claims get paid, even a lot of the claims may not get paid. Some claims are rejected. So that's also can introduce selection bias. So all of these things as a possibility of introducing variety of bias. So what are some of the solutions? How we can avoid this kind of bias? Obviously, one is that you have to look for these things by doing some analysis. But then look at some of the simple ways you could help with these biases. First is Always verify across multiple resources. For example, if you're looking for diabetic code, diabetes patients, don't just look at diagnostic code. Maybe look at multiple diagnostic code presents. Or you can look at medications, you can look at live results. So triangulate across multiple sources will help avoid the bias. Second is combine multiple sources. And this is where combining structured and unstructured data is important. It is not just for finding extra information. It is also validating that whatever is written in the electronic medical record is matching with what is you can see in images and scanned documents. And that also helps you find things which are inconsistent. And lastly, maintain the provenance lineage of the data. Because sometimes you are transforming a field, transforming some tables, to make sure you have audits of all the changes that you have made. And you know which system is sending information at what frequency, when they send the last information, what processes or user is updating your record, and so on. So that way you can verify things if something is wrong in your report. So in summary of what the healthcare data discussion is, obviously you can see because of the fragmented business model, healthcare data is siloed, it's poorly integrated, there's several sources of error, but you can improve your bias by formulating a problem and using a multiple data sources. And of course, healthcare analytics is and data governance is pretty important. As you can see, quality, bias detection, and things should be part of your strategy. Now let's look at how do I create machine learning ready data using the data sets that we just identified in the previous model. There's some other things. I'm not going to talk about the general machine learning techniques like how to do training versus validation or testing, but I'll talk about things that is very important in the healthcare settings. So the first thing you want to do is to organize your data by time, because you may have multiple time window. If you are doing your prediction over 5 years worth of data, you might need that timing factor in place, because potentially what you can do is to use first 3-4 years of data as a training data to predict the last 1 year worth of data. So you have to organize the data by time so that you understand the temporal sequence. And then different types of data is available, and labs and counter medications, vital reports, notes, and diagnosis. And for most of the deep learning model, you may not have to do a lot of feature engineering. You just use a natural element that is coming out, and use sequence model to train this use sequence model as one of the architecture. But one thing to remember here is that in some machine learning, because not everybody is using sequence model, you might have to create a single table of data using the variety of tables that you have, so that you can use traditional models as well. For example, BQML clustering or BQML logistic regression, you might require the data to be in a single table. But once you know this patient timeline and how they are represented, now let's look at the prediction task. Now, what you are really predicting, for whom you're predicting, like identifying the right cohort. For example, whether you're predicting for pediatric visit or versus the adult visits. When you are predicting, the prediction time that I mentioned before, whether it's a 24-hour after admission or 48 hours after admission, things like that. And what's a level you're predicting, like whether it's the length of stay or the readmission, and then so on. And these are some of the details around this prediction task for length of stay as an example. The when, what is the prediction task means the prediction task is when will the patient leave the hospital. And then you have other variety of other things that you have to consider here. Like you can make it like a classification model or regression model based on how you want to present it, the data to your customer. And this is an example of how length of stay data could be created from a FHIR data in a big query. And then the next example is a cohort selection. The set of patients that satisfy some inclusion and exclusion criteria. And there could be two different things here. One is the outcome you're looking at, and there's a second is what exposure you're looking at. Exposure means like you have some kind of symptoms or you have some kind of procedures. That's like exposure. Outcome is whether you're looking good after the surgery and things like that. So those are the two ways you can select cohort. And there's an example here how you selected a cohort based on multiple tables. The key here is I want to select diabetic patient, and I just don't want to use a single table to do it. I use this here multiple tables, like I use the diagnosis table, then procedure table, then labs, and then medications to kind of see to triangulate across and make sure that cohort is a good cohort that I could use. And lastly, the creation of the new feature. Creation of new feature may not be required in most of the deep learning models, but there are kind of three situations why it might be important. One is the aggregation of codes. As I mentioned, healthcare has a lot of codes. Medication codes, instead of using medication code, you can use medication class. And then there are certain scoring fields. Scoring fields like BMI is a scoring field. And then you can classify patients based on comorbidity burden so that you are not mixing up sick patients and healthy people together. And there are a variety of other things you could do, like calculating severity of illness score, which is traditional score that is used in healthcare settings. And then you may be using the knowledge base that you have, you can use add additional knowledge to your data, like socioeconomic and social vulnerability status and things like that. So in summary, there are common issues in healthcare training and because a variety of bias could be introduced. The real data could look different from the historical data and models could perform differently. So you have to be careful while you are creating these training data. And relationship between predictors and the outcome may change over time because better treatment plan could come, new life-saving device could appear, and so on. Now let's look at how you could build and deploy models using GCP tools. GCP provides certain capabilities that is already there to take advantage of, like infrastructure, you have data governance. I talked about healthcare API, data platform, and there are a variety of other things like API management, analytics layer, like BigQuery and others. And then you have AI/ML platform. On top of it, you can create your applications. And there is a simple example of data a pipeline here. Left-hand side is the clinical data coming in, then you're going through harmonization process, and then going through the visualization and machine learning, and then ultimately it will get connected to an engagement application. Specifically, I want to mention a little bit about some of the ML architecture that you could create based on this FHIR data. So you could have the FHIR analytics store, but on top of this, you can apply DID service to create the DID data, because DID data could be utilized for machine learning purposes. And then you can ingest synthetic data that might be needed for a variety of training. And then you can deploy the model using the same FHIR API and use the FHIR API to connect your applications. And of course, behind the scene, we have the model management and model monitoring, but also security and privacy monitoring behind the scene as a part of GCP infrastructure. And you can implement data validation, automated data validation using BQML and the looker. Here, as one example I've given is finding anomalies in unit of measure that you could easily do using either a BQ or a combination of BQ and a looker. And this is the holy grail, what you want to do. You want to discover, develop, and deploy at scale. The first thing you have is the infrastructure. You have the tools, you have the software tools, the AI tools, you have foundation in place. And then because you provide so much functionality like BigQuery, like de-identification, you can discover, develop, and deploy pretty quickly using a standard CI/CD tools that you have. So this is a way you could use all the tools that you have in your GCP environment, and also use some of the knowledge of how to work with healthcare data, and then really scale your modeling and the deployment infrastructure. Now let's go to some GCP demo and show you some of the things that I've talked about here. So first thing you can look at is some of the data that is coming from source system. Like you have this is one of the source system data, admissions and things like that. And then data could be also coming to the message like this. Like this is one of the example of H7v2 message. And using those as an input, you can create your data ingestion infrastructure or data ingestion pipeline using either data flow, or you can use data fusion as well if you are looking for some visual tools. But behind the scene, we provided as a part of data harmonization suite some of the capabilities to map this complex input data into FHIR format. You also provided capabilities to do the code and value set normalization. So once your data is in BigQuery, then you can look at it and see how the data looks like. But the one challenge that you might see is this data is fairly complex to work on. So what I have done is I created some simple views on top of this data, so that while you are working on the machine learning problem, you just look at like a 10-15 fields which might be important from your from the perspective of the models. But you can always use the base tables as well. And this is one example of how BigQuery stores the nested columns and how we can unnest it using the unnest command. And this is what the code looks like in healthcare. Like here, this is a code is for some kind of SNOMED. This is a problem list, like you see here, and this could be stored very efficiently in BigQuery. But when you're doing the query, you can use some of the commands like unnest. And then this is a cohort selection example I've shown you previously, where I'm using multiple tables and multiple predicates to select certain cohorts. And then here I'm using a BigQuery table to create the labels. And once you create the label, the next job is to create single table. Because I want to use AutoML table, then I want to have single table, and this is a function that I use to create single table from variety of patient table that you see, like admission, encounter, procedure, and things like that. And this is available in GitHub as well for your reference. And then once you apply this Jupyter function, you'll be creating this single table like this. You have patient, and they have all the various columns various rows as a column, like observation, diastolic pressure, systolic pressure. These are now become column, like a feature in your machine learning model. So now let's look at how we can apply AutoML on top of this. So I actually already ran the model for you because it takes time to run it. So first you need to go to import and give the name of the BigQuery data set that you just created, the ML ready data set. And then you go and train. And so one of the things is I used here standard splitting mechanism, 80, 10, and 10. But you can actually use variety of the splitting techniques, like time column you can use, or you can manually create your splitting. In healthcare, sometimes time is used as a splitting because you want to predict the last 2 years worth of data, maybe using the first 5 years worth of data. So I think those are the kinds of things you could do in changing the splitting parameter. And then once you ran it, train the model, you have to click on the train model. Is going to train for a couple of hours, and then you can see the value for the evaluation of the function, evaluation of the model. So this is one of the ways to quickly create the model. And I can see in healthcare, you have to create multiple models. There is no one or two models that will be useful because you have a variety of challenges in the data, you have biases, you have the representative issues that I mentioned already. So in many problem will require multiple law model. That's why the AutoML is very useful because you can quickly create a lot of these models based on your cohort that you have in your on your data, and may have like hundreds of models corresponding to a single problem. And then there's a evaluation, available evaluation metrics, standard evaluation metrics, ROC, etc. And also you can see confusion metrics that is used in healthcare or any machine learning settings, and then features of importance and things like that. And then you can actually test it and in your using the model either in a batch prediction mode or in an online prediction mode. So that's it for today, and thank you everybody for attending, and I look forward to working with all of you in expanding machine learning in healthcare settings.